Welcome back, my dear students. In the previous class, we have learned the different types of images that have been formed by a convex lens. So, today we'll learn how to calculate the position and size of the images using some formulas. So, let's start this session with sign conventions. So, we have already learned the sign conventions for lenses. So, let's see. This is a convex lens. So this is the principal axis. You need to remember it carefully. Principal axis. All the distances are measured from the optical center. Optical center F1, F2, sorry, 2F1, F2, and 2F2. Right? So let's draw a line. It is coming towards like this, right? So let's say these lines are called incident rays. So you want to measure any distance. All the distances have to be measured from the optical center itself. You want to measure f1, so you have to measure from optical center to here. You are not allowed to measure from here to here. This is the wrong method. So you have to measure from optical center to here. You want to measure the distance between optical center to 2f2. You have to measure like this, optical center to 2f2. But measuring here to here is the wrong method, right? So here to here, it has been measured like this, not like this. You get it? So optical center to any point you want to measure. So let's say that's the first point. All the distances are measured from the optical center. You need to remember it. So next point, direction of the incident light is considered always positive. So let's say this is an incident ray. Incident ray direction is towards this direction. So it has been considered positive. So the direction of this light ray is considered as a positive direction. If the directions, if anything is measured opposite to the direction of an incident ray, so incident ray is coming towards like this, but we are measuring the distance like this, right? It is considered as a negative value. If any distances are measured in the direction of incident ray direction, those are considered as a positive direction. So you have to remember everything. So let me clear it one by one. Okay, let's start with this. First situation is object distance. U for object distance. So object distance is always placed in the left side to the lens. So it is always placed left side. So U is always negative. U is always negative. So focal length always taken as here f2, because incident ray is coming towards like this. After refraction, the light ray passes through the focus. So you are going to consider focus as here. So focus is positive. So coming to the image distance, depends on the image position. There are many of the situations image is going to be formed towards like this, right? Other side of the mirror, right? So it is going to be measured like this, means V value is positive. No need to worry about it. But at only one situation, when the image that has been formed is virtual and direct, the image is going to be formed here, this side. So that is considered as a negative value. So negative value. First 5 situations it is positive, and next only one situation it is considered as a negative. Clear? For a concave lens, if you consider a concave lens, For a concave lens, focal length is considered as a negative value, because for a concave lens, the image is going to be formed at the same side of the mirror. Okay, we'll discuss about this thing in detail after completing the convex lens. Okay, don't get confused. So let's visualize lens formula. So formula for lens formula is 1 by f is equals 1 by v minus 1 by u. So minus indicates lens formula. If there is a plus 1 by v plus 1 by u, it would be going to become a mirror formula. Did you remember the mirror formula over there? Right. Mirror formula is equal to 1 by f is equal to 1 by v plus 1 by u. Lens formula is 1 by f is equal to 1 by v minus 1 by u. F means focal length, v means image distance, and u means object distance. Let's see the magnification of lens. Magnification. So magnification tells us how the image is enlarged or reduced. How the image is enlarged or reduced. So that is going to be told to us by the magnification value. So the formula for magnification is m is equal to hi by h naught, or it's v by u. So this is the magnification for lenses now. But coming to the mirrors, m is equal to hi by h naught, but here minus v by u over there, but plus v by u here, right? So keep that in mind. You need to compare carefully. M is nothing but magnification, hi, height of the image, and h naught, height of the object, right? If the magnification value, if m value is greater than 1, if m value is greater than 1, image formed is enlarged. Which image is formed? It's an enlarged image is formed. If m value is less than 1, what does it say? The image formed is diminished. If m is equal to 1, which means magnification is equal to 1, the size is same size. Image formed has a same size. Okay, let's see the numericals that are related to these up to now. Okay, let's start with the first question. Examples. Okay, after completing the concave lens also, on concave lens diagrams and numerical problems, after completing it, we have some example problems that are given in the textbook. Textbook example problems, and after completing the example problems, we'll cover exercise problems. After completing the exercise problems, we'll cover in-text questions also, right? So everything will be in detail, it has been covered. Clear? So keep that in mind and prepare carefully for 10th exams. Okay. So first problem, a convex lens has focal length. A convex lens has focal length 20 centimeters. An object is placed at object, which is nothing but u. Object is placed at 30 centimeters from the lens. Find the image distance. V is equal to question mark. Right? These are the values, right? But carefully, in a convex lens, f is taken as positive, u is taken as negative. Right? Let's find v value. You know the lens formula. Lens formula 1 by f is equal to 1 by v minus 1 by u. So 1 by 20, f value 20, v value v, I don't know. We have to find v value 1 by u value minus 30. Here when you become minus into minus, it is going to become plus, right? 1 by v plus 1 by 30. So let's send 1 by 20 over here, 1 by v to that side. We'll get 1 by v, not this. Okay, let's say instead of sending 1 by v, let's send 1 by 30 over there. You'll get 1 by v is equal to 1 by 20 minus 1 by 30. It is going to become. Get it? right? 1 by 20 minus 1 by 30. So if you do the LCM for 20 and 30, you will get 60. So into 60, 20 table 60 goes for 3 times, and 30 table 60 goes for 2 times. So 1 by V is equal to that 3 minus 2, 1 by 60. If your reciprocal is V is equal to 60 centimeters, right? So image is formed at 60 centimeters from the lens because image V value is positive. Next question. Question number 2. An object of height 5 centimeters. Object of height, right? Let's say object height 5 centimeters forms the image of object. Sorry, image height 10 centimeters. Find magnification. It's equal to question mark. So this is the question they are asked. Right? You need to find the magnification. So it's a very simple question. You know the formula m is equal to hi by h naught. Hi 10 by h naught 5. 5 ones are and 5 twos are. So magnification is 2. Right? So is it greater than 1 or less than 1? It's greater than 1. So image is enlarged. Right? So these are some of the questions that has been asked. Tell me what is the lens formula? 1 by f is equal to 1 by v minus 1 by u. So this is the lens formula. Okay. What is the SI unit of focal length? Focal length SI unit is meter, METRE. You need to remember it, meter. Which lens has a positive focal length? So convex lens has a focal length is always positive for convex lens. So what about concave lens? Concave lens has a focal length that is negative. You need to remember. These are the major points you have to remember, right? So for 1 mark also they are going to ask what is called magnification and write the formula. Magnification is the ratio of height of the image by height of the object. Height of the image by height of the object. Sometimes when the heights are not given, you are going to measure by using the image and object distances. So for 2 marks, they might go ask like this: write any two differences between convex lens and concave lens. So coming to the convex lens and concave lens, For coming convex lens, it has a positive focal length, it has a negative focal length. It converges light, it diverges light. So 2 points. Also, it always forms real and virtual images. It always forms virtual and direct images. Right? So in the next session, we'll start a concave lens ray diagrams. After completing the ray diagrams, we'll discuss about the lens formula, sign conventions, and everything will be detailed. In detail, we'll cover. Okay. Thank you.